Good evening, ladies and gentlemen. This is Miss Hurst and Mrs. White again. Section 2.6, this time we are going to prove that angles are congruent. There are going to be several theorems and postulates, but we're not going to write them down. We just expect you to listen carefully for them and remember them. Okay? So we're going to start with some algebraic examples. And again, listen carefully. We're going to use some of the theorems that are found in this section. For example, vertical angles are congruent. Okay, so that means that this angle right here is congruent to this angle right here. So I can mark that with my arc. Now, what that means, if we were writing proofs, we'd go through a whole long statement of angle blah, blah, blah is congruent to blah, 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 then they're equal, and then we can go ahead and do substitution. But we're just going to start at x plus 10 equals 4x minus 35, and we're going to solve that problem out. So go ahead on your own and solve that, and we'll see if we come up with the same answer. I'm not going to show you my steps. You guys should be experts at algebra at this point in time, and you should get that x equals 15. Okay. Now, question number 2, again, we've got vertical angles. We've also got supplementary angles. I've got a linear pair right here. So these two angles are going to add up to 180. So all linear pairs are supplementary, all straight angles, if they have a ray that comes off of them, do create supplementary angles. Okay? We might need to use that information in just a minute. But first things first, vertical angles are congruent, so therefore I can set these two angles, 5x minus 20, equal to 3x plus 8, and solve. Okay, so after you do your algebra, you should come up with x equals 14. So now how do we get from there to finding out what y is? Well, I'm going to take this, I'm going to plug in the value of x using substitution, so we know that this is 5 times 14 plus 4y. 5 times 14 is 70, so we have 70 plus 4y. Like I mentioned earlier, we have a linear pair, so I am going to plug x back in to either 3x plus 8 or 5x minus 20, just one of those. If I plug it into 3x plus 8, so we have 3 times 14 plus 8, I'm going to end up with 50. Alright, so I'm going to label that. This angle right here is 50. So what do we know about linear pairs and supplementary angles? We know that they add up to 180. Awesome. So we're going to go ahead and say that 5x plus 4y plus 3x plus 8 equals 180. And I'm going to replace it. We already figured out that 3x plus 8 was 50. We figured out 5x plus 4y is actually 70 plus 4y. So we know that these add up to be 180. Go ahead and take some time. Go ahead and solve that for y. And you should get that y equals 15. So we have y equals 15 and x equals 14, using the two theorems and postulates that vertical angles are congruent and linear pairs are supplementary.
Okay, so now we're going to look at a proof that has that vertical angles are congruent, that theorem that we just talked about. So here's a proof. So go ahead and copy down the diagram, and remember, copy down the given and the proof, and we're going to fill in the blanks. So remember, the first reason is typically the given, so all you have to do is look at the given and rewrite the given. So step 1 will be angle A is congruent to angle BDA. So that's our first step with the given. The second reason tells us vertical angles are congruent. So what we're going to look at right now are some vertical angles. If we noticed, these two angles right here are vertical, and I'm going to use those two instead of these two. And the reason why I'm going to use those two in the arcs is because in the proof it gives us that 12x plus 15 is that one vertical angle. So I know we're going to use those two vertical angles to show this. So vertical angles are congruent. We need to go ahead and say that the measures of angle, let's see, vertical angle, remember we need to name our angles properly, and we're going to name it with 3 letters. The measure of angle BDA is congruent to the measure of angle, what am I doing, BDA, so EDC. And actually, I made a mistake. Did you guys catch what I made? Since we're doing congruent, we don't need the little measure symbol, so I apologize. Those numbers, I can say that the measure angle BDA is equal. So, vertical angles are congruent. Angle, oops, I erased some part of my angle. Angle BDA is congruent to angle EDC.
Do you guys see what I see? Do you see angle BDA is here and here? And then it is no longer in statement 3. But kind of like law of syllogism, which we talked about earlier, and the what property?
Transitive.
Yay! We've got the transitive property happening here, and it's okay that this is EDC and this is CDE. They're representing the same angle. Remember, there are different ways to name each angle. So we have angle A is congruent to angle EDC, or as we wrote it here, CDE, because of transitive property.
All right, so now that we have the transitive property, step 3, let's take a look from step 3 to step 4. Well, step 4 says the definition of congruence. So remember, the definition of congruence is that you're going to be taking a physical angle of something being congruent, and we can now say if they're congruent, then we know that the measures of those angles are going to be equal. So that's what the definition of congruence states. So measure of angle A is equal to the measure of angle CDE. Okay, so now going down, now we're going to go from step 4 to step 5, where we had angles, and then now we have a representation of numbers. So if you can remember from before, we are substituting those numbers in because we are told that angle A is equal to 11x plus 20. That's in that diagram up here. And then likewise, the angle CDE is represented by 12x plus 15. So that's the substitution property. That's not the right substitution property. All right. And that's the equality symbol. So now let's go ahead and finish and solve this equation. From step 5 to step 6, it says subtraction property of equality. So I'm going to subtract the 11x from both sides, which will leave me with 20 equals x plus 15. Okay? And then our last and final step, because on the proof it wanted us to solve for x, so we're going to go ahead and subtract 15 from both sides. Let me put x on the other side. If I subtract 15 from both sides, I have 5 equals x. So that's subtraction property again.
And you could go one step further and write it so that it says x equals 5. Remember, that's your symmetric property, but we're perfectly fine leaving your proof at this stage. This does confirm that x does equal 5.
All right, so let's continue with our proofs because we know you guys love them. So at this point, you've done several proofs. We worked on proofs the day before. So go ahead and copy all this down, pause it, and see if you can go ahead and fill in the blanks on your own given this proof.
Okay, so first thing I would do, Ms. White instructed us earlier that we're going to label the information as if we were just going to solve for x. So I've got my angles labeled. I've got my main angle is 40, and then here are the rest of the answers to the proof. Okay.
So hopefully you don't screw up on the first step because that's just recopying all the given. And then like we were doing the segment addition postulate before, this is just angle addition postulate. If you read through the measure of angle PSQ and look at your diagram, that's part plus part equals the whole thing. So angle addition, and then from there, once you get angle addition, you can substitute and do all your algebra work. So let us know if you have questions tomorrow on this proof. And once again, we're going to work on proofs because we know you guys love them so much.
So know your vocabulary, know your definition, know your theorems, and we will work on that again tomorrow.